Hello everyone, this is Professor Ma and this is the introduction to the sections on complex numbers. We have real numbers, so if I type into my calculator, ask for what square of 5 is, and the answer is roughly 2.3 something, 2.34, something like that. But the point is this number is we call a real number. What I mean by real means it's measurable, tangible. I can try to measure out square of 5 pounds of cheese because there's a decimal approximation for it. So therefore, these numbers, this type of number, we say they are real. What type? Decimal numbers that I can physically obtain the measurements close to it. But then if I were to ask what is this, the square of minus 5, and no real number can do this. No answer, no real number, because any real number, if I were to square, I wind up with a positive number. Okay, I'm not going to give minus 5. Well, even though it's not a real number, I can still invent a system to accommodate these type of questions. And that's what we're going to do. And the new system we invented that's larger extend beyond the real numbers, and these numbers are called complex numbers. So in particular, okay, how do I make new numbers that so it can accommodate square of minus 5? Well, basically we do it in the following manner. We define square of minus 1, and we call it, because for easy writing, we just call it things I. And the property of I is if I square I get minus 1, positive or negative I. In this case, I can answer questions like what numbers square give you negative 49? And the answer is, well, square of 49 is 7 times I. Okay, I can take the 49 out, and the square of 49, I know what that number is. It's a 9, and then still have the square root of minus 1, and another component, and we call that I. So we can write the answer as 79 plus minus. So it's a new number that we invented just to play around with. It turns out to be extremely useful. Okay. Although it's not real anymore, it's not measurable. Now, from that number I, we're going to make up new numbers together with my own numbers, the real ones. And I'm going to take the real numbers and put into another component, add another component. We call the other components the complex, the imaginary part. Okay, and the combination of these two items, two parts, and this number we call, this type of number we call complex. And all these numbers are complex numbers. Okay. And you can identify which part is real, what is the real part, and what is the imaginary part, clearly. Okay. And we can add subtract them. And when we do that, we treat the I like it's an X. So I plus I is 2I, and 4I minus 3I is a single I. So we remove the probability collect I. And subtract, same thing. You can multiply them and FOIL and multiply out like though with the I. The I is a letter, so it works exactly like X when multiply. So you FOIL, but when we FOIL that out, we're not done yet, because now I square has can be replaced by -1. So if we do that, it changes the sign. It changes the sign in front of the from the minus to plus. If it is a plus 21i squared, it will turn to minus. And you get a number. And that number goes to the front. What I mean goes to the front, it always then combine with the the number, the other number, real number in the front, multiply the 4 times 2. They goes, the front one and the end one, they goes together. The two middle i's goes together. And then you wind up with the answers. So that's how we multiply. And out of these multiplications, the conjugate multiplication is the most important one because that one, we use it to help us to divide. Okay. What's the conjugates? Number is a plus and minus sign difference. And the points about when I multiply the conjugates is a minus b times a plus b, and I will get the square of a minus square. So if I have square of 5 minus 3, 5 plus 3, I'm going to get root 5 squared, which is 5, minus 3 squared, which is 9. So that's how conjugate multiply. Now, if I stick an I in there, I in there, and here the square is bi squared. And the consequence of that is going to change this into a plus. In other words, if it comes with I, then this will be, the formula will be, for instance, it will be 3i minus plus 3i, then I will get a 9i squared. The I squared times 9 is plus 9, so I actually get the answer 5 plus 9. I will get 14. Okay. So here's conjugate multiplications. And we're going to take advantage of that to divide. So here's an example of multiplying. So if I see these conjugates, basically the way I see it is, oh, it's conjugates. So 4 times 4 is 4 squared, that's a 16. Now I look at the other number, 3 times 3 is a 9. And then what I do with the 16, I add them because they're complex conjugates. So you wind up 2 number adding. Answer is always positive for complex conjugate multiply. We use that to divide. Okay, and what it means to divide? What we meant is I want to find out what complex number a plus bi is. What's a quotient that will turn into as another complex number. There's no meaning if you try to think of the old meaning of 6 divided by 2, and it's like 6 over 2. It doesn't carry over. How do I divide by complex number? So we don't do that. We don't do that. We do what? We skirt around the problem. We change the problems by using the complex conjugates of the denominator. Okay. And why? Oh, because now if I do that, then the denominator transforms into 4 squared plus 3 squared. That's a real number. And the top can FOIL it out, whatever it is. And it turns into questions of dividing by 25. So that's how I get the complex answers for divisions. Okay. And then what else? Notice, here it is. Powers of I squared is minus 1, I third power is minus I multiplied by another I to both sides. Then multiply another I, then I get I to the 4th is 1. Then they go in cycles, 36, 7, 8, 8, stuff like that. Okay. And then the final things I want to know is that when we solve a second degree equations, and the answers, if it's complex number answers, then because of plus minus in the quadratic formulas, I always get complex conjugates as two answers. So if I have a second degree equations with real coefficients, the complex solutions will always comes in conjugate pairs, the +1 and -1. Okay. And that's it. Go home and do the homework and have a good day. Let me go stop here.